All right, welcome everyone to Wide Area Networks. We made it to here. Excellent. All right, when we're doing wide area networks, there are some terms that you need to be familiarized with. Some of you already are, but if you're not, you're about to. CPE, that is your customer premise equipment. That is what you own, right? What's inside your facility. That is your equipment, okay? CPE. The next one is demarcation point. Obviously, you go connected to the demarcation point. Up to the demarcation point is your responsibility, your equipment. Beyond that, that's their problem. Why is that so important? Because if it's beyond the demarcation point, meaning it's outside your facility, they got to come out and fix it. That's on them. That's on their dime. But if it's on the inside and they got to come in and fix it, that's our dime. All right, that's what's the big difference. Now, the local loop does connect the DMARC to the closest switching office. Local loop does connect to the closest switching office, which is called the central office, which connects to the customer to the provider, which is also known as POP or point of presence. Point of presence. Okay? And the toll network, that's what's happening inside. Anytime you look at a picture of a cloud, what you're looking at, this wide area network symbol that encompasses routers and switches and servers and what have you that's in there, that's passing your information along from point A to point B, okay? So that is the toll network. So these are just basic terms that you need to be familiarized with because trust me, when you call your provider and you tell them, hey, listen, I ain't got no internet, they're going to try their very best to make sure that it's not them, that is something beyond the demarcation point inside your facility. So it's your CPE, your customer premise equipment that has the issue, not them. 9 out of 10 times, it is them. All right, that's having an issue. So know those real well and the consequences that you're going to be facing. Okay. The next thing are connection types. Well, there's basically 3 connection types. You got lease lines, circuit switching, and packet switching. Lease lines are dedicated connections. I made the first mistake when I started long time ago a business where I said, hey, let's get a T1. A T1 is 1.544 megabits per second. We should have no issues whatsoever. Yeah, well, that wasn't the case. Even though it's a dedicated connection, it was a point-to-point. They would consider that a point-to-point. I had the full bandwidth at all times. I had 1.44 megabits per second at all times. But at midnight, nobody's doing anything. You may be doing a backup or something like that, but nobody's passing information back and forth. So do I really need that 1.544 megabits per second? Not that it helped me any during the day, because that was not a very good idea. Everything just slowed down tremendously. But anyway, so when you get a lease line, you're going to be paying. It cost me back then, I don't even know what year it was, over 10 years ago, let's say. It cost me over $400 a month to pay for that lease line. I don't know if it was 10 years ago or 7 years ago. I don't remember. Let's say in between 7 to 10 years. I don't know. But it was $400 a month for 1.544 megabits per second. Are you kidding me? Well, I mean, now this is, what we have now. But still, it was not enough, even though it was a lease line. And I was paying for that bandwidth at all times. That's the problem. That's the problem. But if you had the money and pay for it, that's fine. And if you get out of your contract, because when you call provider, yes, I need a T1, please. Yes, I want the bandwidth at all times, please. I got to pay what? And if I leave early, I still got to pay. So be very careful. Now, circuit switching, you don't want. I mean, I still think when you go to check caching places and things like that, I still hear dial-up. Actually, not too long ago, these past couple of months, I've been going to the hospital, not for myself, but for a family member, take care of some medical issues. And I would take out money from an ATM. First time I hear an ATM made that dial-up noise. I was like, are you kidding me? They're using dial-up? Seriously? Okay, whatever. So when you think of circuit switching, think of dial-up. That's the type of speed. ISDN. You're not going to get much speed out of that. All right? Packet switching is what we're normally used to. When we use packet switching, we use frame relay X25. Now MPLS, because MPLS is replacing the frame relay technology. What's so good about packet switching? Well, with packet switching, you can make it look like a lease line. When we get to frame relay, we'll discuss a little bit deeper. But with frame relay, you're sharing your bandwidth. You pay for what you use. You pay for what you use. That's why you see in all these office buildings, they got, let's say, 2 or 3 T1s. Well, those two or three T1s are being chopped up in 64 kilobit chunks. Everybody has the capability of going up to that particular speed, but it all depends in something called your CIR, your committed information rate. But packet switching is the way to go at a very low cost, not a very low cost, but a low cost, lower than lease lines for sure, low cost. And we could make it based on CIR and burst and all these different things. We could make it look like a leased line. So those are different types of connections that we could use. But just remember, frame relay is being replaced by MPLS. Now, HDLC, PPP, and look at our MPLS right there. HDLC is proprietary to each vendor. That's the main problem, and that's what you're going to see in your certification, okay? That's what you're going to see. HDLC it's not aware of the upper network layer protocols. So each vendor puts on its own information. So if you have a Cisco router and a non-Cisco router and you're running HDLC across serial lines, well, you're not going to communicate, period, because it's going to be a mismatch encapsulation. All right, so that's the problem with HDLC. HDLC. That's why the one everyone likes to use is PPP. It can do many things. One is an open standard. You can go across different routers. It has protocols to build and maintain data line connections. It allows multiple network layer routed protocols, such as IP, IPX, things of that nature. Okay, so and PPP would be the way to go. You can aggregate lines. You can get a whole bunch of PPP lines and put them all together. So it has authentication in it. It has a lot more features than HDLC would ever have. But again, it all depends what you're running and what you want to run. If you're running all Cisco routers and you want to run HDLC, hey, more power to you. Okay? But if you're running in a mixed environment, PPP would be the way to go. Now, MPLS, as it says here, is a switching mechanism based on labels. MPLS, number one, is dependent on IPsef. It is also dependent on IGPs, inter-gateway protocols, such as RIB, HRP, and OSPF. So, but it's based on labels. Labels. It gives a label as it goes throughout, and we'll talk about those, okay? It'll give a label as it goes through the different routers, through the MPLS backbone, if you would, okay? And using the CEF table, it's already prepended where you need to go. So things will get there a lot quicker. We'll get there a lot quicker. MPLS. It is designed to support forwarding protocols other than TCP/IP, so that's good. And MPLS is, I already told you that, MPLS is replacing frame relay. Everybody's pretty much using MPLS. The only people that are not using MPLS is because either they don't know it, they don't want to know it, they're scared to know it, their hardware doesn't allow it. I don't know. But today's world, you need to be running, if you're running any mid-sized company or higher, you need to be running MPLS in your wide area network solutions, because it's just going to be better for you when you're transferring information across a wide area network. It will be much quicker, much quicker. All right. Now, PPP. PPP works in this fashion. You have phases, right? When it makes a link to its neighbor router. First, the LCP, right? The link establishment phase. It sends packets to configure and test the link. So I first say, hey, are you working? I'm sending you stuff. Are you up and running? Authentication, which is optional, but we're going to configure authentication. And you can use both CHAP and PAP at the same time. If one fails, the other one will take over. And network layer protocol phase allows multiple, again, routed protocols. So LCP is a very good, it's one of the features that it has that helps us create this particular session. All right, and this is the configuration. Very, very simple. Very, very simple. In the interface, you put encap PPP, PP authentication chat PAP. In global configuration, username router 2, password Cisco, case sensitive. Case, and they like to play with that in exams, case sensitive. If one router has Cisco and the other in lowercase, and the other router has Cisco, but the C is uppercase, guess what? No, sorry, I'm not going to talk to you, okay? Because they're different. So it's case sensitive. Now, let me just slow down here, okay? The username is actually the host name of the other router. So this would be router 1. And I'm going to have router 2 as a username on my router, and his password is going to be Cisco. Hence, router 2 is going to use router 1 as a username on his router, okay? And he'll put the appropriate name, okay? Username router 1, password Cisco. So real, to be honest with you, in all my teaching career, this has been the biggest confusion in the world right here. So the host name of your neighbor router is your username on your router, and it is case sensitive. Okay, it is case sensitive. So be very careful with this PvP. Easy configuration, as you can see right here. I'll get out of it. There you go. You get a smile and everything. All right, but you'll have this configuration, so don't worry. Frame relay. Frame relay. Yes, you're not going to have HDLC. You're not going to have PvP. The actual encapsulation is frame relay. All right. And we talked about earlier about a CIR. What is that? It is a committed information rate. This is when you call in. Yes. Well, what kind of speed do you need, sir? Well, I need a CIR. What does it say there? A CIR of 256 kilobits per second. I need that. I must have that. You must guarantee me that 100%. All right, sir, we will guarantee you, and this is the key word, up to 256. Did you catch that? Up to 256. That means it could be 56 kilobits per second up to 256 because you're sharing the bandwidth. So when everybody comes to work and you work in an office building, there's different, lawyers and architects and doctors and yoga people, whatever. You're going to share that bandwidth. So when everybody's on that same T1, guess what? You're not going to get your 256, but they'll guarantee you if nobody else is using it that you'll get it. But there's also something called an access rate. This is the maximum speed at which frame relay can connect or transmit with that particular connection. All right, so you can get an access rate as well, but you're only guaranteed the CIR. Now the burst is anything exceeding the CIR. And anything exceeding that burst, you're done. Nothing's guaranteed. That's why in frame relay we have called DE bits. DE bits. Discard eligibility bits. When you do that, when you look at that, it'll show you how many have you dropped. So that way you can go back and tell your boss to say, hey, we got a lot of DE bits, man. We're dropping a lot of stuff. We need more bandwidth. Look what's going on. Obviously, you're going to be running some sort of SolarWinds control panel that's going to have all this information in nice, pretty colors and charts and bars and all these things that we know management, the upper level echelon, like to look at. So you can say, oh, well, yes, this is a beautiful graph. Yes, I can see how the bandwidth is being taken up. And then you can go ahead and give it to them and they'll say, okay, we'll approve that. And they'll give you more bandwidth. Okay, so, but you need to make sure, you need to be looking at this, monitoring that, because that's usually the problem. Now, this guy, when configuring frame relay, the preferred method is using sub interfaces. Why? Because some people use RIP, right? And we're talking about a non-broadcast multi-access network. Okay? So when we use RIP, what happens is it creates that split horizon. Do not send me back on the same line that I just updated you. And it's like, well then we have an issue. So we won't have connectivity. So to get around that, we create sub-interfaces. Now these sub-interfaces, you do it just like you would do VLANs, okay? When we're doing inter-VLAN routing. These sub-interfaces are called PVCs, permanent virtual circuits. Now these permanent virtual circuits, how are they identified? They're identified by the data link connection identifiers. And who in the world gives you these data link connection identifiers? Your provider. Your provider. You don't make them up with thin air. They give it to you. All right, so you put these DLCIs per PVC, and that's how it's going to know, because inverse ARP is what's working there now. It's a mapping of a local DLCI to a destination IP address. So when your provider sees that, oh, okay, he's in that DLCI, he's going to this network, I know where he needs to go. Okay, so that's what DLCIs are, data link connection identifiers, that identifies a PVC on the local router. Okay, now and here is your frame relay configuration. It is not hard. It is not hard at all. All right, and you're going to have it. I'm going to step out of the way. I'm going to make sure I'm not in the way so you guys can see it, and you'll have it. Don't worry. Okay, so interface 030, no IP address, in-cap frame relay. That's in the actual physical interface. Then you create your subinterface. As you do in VLANs, the subinterface should have the DLCI number. That way you know when you look at it what you're looking at. All right, and you must put point to point, because it is point to point, isn't it? You're going from here to there, from this router to that router, and from this router to that router. So it's point to point. All right, and then you put the IP address, and then the frame relay interface. This is how you're going to identify that particular subinterface. Interface frame relay interface DLCI 102. And do the same thing for as many, right? Putting the correct DLCIs, all right, and the correct IP address for each one of those PVCs or subinterfaces, all right? Then this is your wide area network. Now, obviously, I didn't talk about MPLS here, but I will talk about it later. That's its own animal, okay? So we're going to go ahead and end this here, and I'll see you in the next. Okay, then. This is our PPP lab. All right, you can see this is our hub router, and we got our spokes coming out, right? And you see the clock rates are going to be around here. The only thing you got to be careful with is when you see the interfaces, make sure that you're going into the right interfaces. So if you're following along in the lab, make sure you're going to the right interface or this will not work, okay? We're going to take it around. We're going to do a spoke first, and then we'll do the hub last, or the hub last. We'll see how when we get in there, how we do it. All right, but again, it's a very simple, straightforward configuration. You just got to make sure every part of it gets done. So with no further ado, let's get inside the lab now. Welcome to the PPP lab. All right, we're going to go ahead and configure all these routers to use PPP. Now let's talk about our topology so we can know exactly what we're looking at. We have all serial interfaces, obviously. We just got to make sure that we're with the right serial interface. You see this one is connected to the S011. This one is connected to the S00. This one to the S001. And this one to the S10. We really need to make sure that that's correct. Now, in order to do PPP, especially for the authentication, we must have a host name on the router. So all these routers will have host names. All right. And then we'll get into the IP addresses, obviously, and then we'll get into the configuration of PPP. And we're all connected to the same router, so there will be no need for, well, there is really, because we want to go between routers. Well, I don't think so. I think we should all be directly connected. We don't need a routing protocol. All right, so let's go ahead and we're going to do the outside routers first. We'll start with router 1 right over here, and that's why I put that lab way over there so I can expand the router. And we have enough room to work with, and we can see everything perfectly fine. So we're going to enable, we're going to conf T, we're going to name the router, host name R1. All right, and we'll go to the interface as 0/0/0. Now you can see this is going to be a DTE. All the clock rates are in the middle, so we don't have to worry about that. IP address. The one in the middle will be the last router we configure, 10.1.1.5, 255, 255.255.252. We do no shut and do WR. Done deal with that particular router. Now we're going to go to router 2. All right, bring it over here. We'll open it up. Say no. We go enable, config T. All right, and then we're going to do host name, obviously. Router 2. And then interface S0/0/0. And this is going to be an IP address of 10.1.1.9, 255, 255, 255.252. And then no shut. Remember, this is the DTE portion of the cable, so there's no need to put a clock right on there. Do WR. We are done with that. Now we're just putting the basic stuff in there so we can start doing PPP. All right, let's put this bad guy up here. This is router 3. I'll say no. Enable, config T. Host name, tap that out, R3. Go to interface S000. That's what I like to call it. And then IP address 10.1.1.13, 255, 255, 255.252. No shut. Do WR. Done deal with that. And then we go to our last router. Well, not our last router, but router 4. And then we'll configure that bad boy. Enable, config T. And this, again, this is basic stuff that you already should know. Host name, not hot, host name, R4. Interface S000. Now you can see I try to make things simple. Not to, oh my God, what interface is this? No, we're learning a concept here. So we try to make it as easy as possible. IP address. This is the 10.1.1.17, 255, 255, 255, 252. And then do WR. So all the perimeter routers, or the spoke routers, have their IP address and host name. And now we're going to do the same thing for the middle router. Okay. Did we not? That's funny. Why does the other routers have green lights? Did I erase start? I didn't. Okay. So we're going to enable. And I'm going to erase start on this guy, because we never did. Reload. And we don't want any configurations on that middle router. We want to do it ourselves. Everything from scratch. Okay. I'll say no. All right. So remember, you got 4 interfaces you got to configure here. Config T, but we still need a host name. Host name is R. Well, I'm assuming this is R5. Right? No, R0. Wow, how about that? R0. Okay. So then we'll go first to router 1. The connection to router 1 is S0 S000. Sorry, matter of fact. Yep, that's it. S000. So we go to S000 int S0000000, and we do IP address. And we got 10.1.1.6, 255, 255, 255, 252. Clock rate. Now this is the DC portion. We need to put the clock rate in there. 1, 2, 3, 4, 5, 6. Okay. And then no shot. Boom. That green light turned on. Then we go to S001. S001. All right. IP address. That's 10.1.1.10. 255, 255, 255, 252. And then clock rate is the DC portion. Clock rate 4 million. 1, 2, 3. 1, 2, 3. No shut. Boom. Green light. Awesome. Awesome. Let's clear some space here. Then we go to interface S0/1/0. All right. Then we go IP address. And 10.1.1.14. 255, 255, 255, 252. Clock rate. And 4 million. 4. 1, 2, 3. 1, 2, 3. Everybody's paycheck. No shut. That's done. And then we go to our last router, and that's S011 int S0/1/1 IP address 10.1.1.18 255 255 255 252. No shut. And we can verify connectivity simply. I mean, we have it in the routing table, show IP route. We're connected to 3, 4, 8, and 12. 4, 8, and 12. What happened to 16? Did not no-show that. In S, let's go to config T. See, that's one of the things you must verify. You must verify. Int S0/1/1. Let's do a no-shut. And okay. Let's see what's going on. Let's do a show start. Let's do a show IP and brief. Let's take a look first. Show IP and brief. And we have the 6, the 10, the 14, and the 18. It's down. Let's take a look at the other side. So if that side is good to go, this is 17, 252, S00. Oh, there's no shut on that one. Okay. No shut. There we go. Now it's up. All right. So we go back to our router 0. We do have, now in our routing table, we have connected directly to 4 of these routers. Now, if you look, just pick any interface. Let's say show interface S0/0/0 and or show IP. Oh no, hardware encapsulation right here. HDLC. They're talking using the HDLC protocol. We want to convert this to PPP. All right, we want to do PPP. Not a problem. All right, so we already have part of it done, which is the R0, which says, hey, we have to put the host name in there. We're going to do PPP authentication. So if you look at it, if you go through here, all right, there is no PPP under global configuration. So we need to go into the interface S0/0/0, and we do, there's a, so I'm going to show you there's a command, encap, right there, because I want to take you step by step, okay? So you do encap, you don't have to write the whole thing, all right? And then you decide, what am I doing? Well, I'm doing PPP, not with 4 Ps, only 3. And then that's it, encap PPP. Now you see I went down. It went down because there are different encapsulation types, all right? So we're in the middle router. And we're also going to do PPP authentication, right? So if you do PPP, and you do question mark, there's the authentication. Authentication, you have PAP. All right, you could also do CHAP. Which one you do first is the one that's going to happen first. And if that one fails, then the other one takes. So you know what? Let's do CHAP, PAP. Let's do both. Okay, so we got now that. And also one thing we neglected to do, in global configurations, in order for this authentication to take place, now, router 0 is connected to 4 different routers. 4 different routers, right? So you're going to say username is going to be R1. Password, Cisco. Now, we got 4 routers to do this to. All right, so we're going to do it. We're just going to up arrow. We're going to change it to router 2 because they're the ones that are trying to connect to us, right? And then router 3. And then router 4. Oh, sorry. Wrong arrow key. All right, router 4. There you go. So in global configuration, you did the host name and you did the username as well. All right, the username of your neighbor router, which is the host name of that router. Because R1, R2, R3, R4 are the host names of those particular routers. Okay, so that's going to be the username. And the password Cisco is what they're going to use. So that has to match on either side. If there's a mismatch anywhere in spelling or password, obviously, they're not going to connect either. All right, do WR. So, we got to do the authentication on, we got to finish the int S001. All right, so let's go there, int S0/0/1. We're going to do encap PPP, went down, and then you're going to go PPP, authentication, CHAP, PAP. Simple. PPP is not that difficult, at least for what we need in the certification. All right, let's go to this router. We're already in the interface, so that's awesome. So we're going to do encap PPP, and then we're going to say PPP authentication chap PAP do WR. Done deal. All right, and then what's the other one? S011. Okay, because we just did S00. Oh, I came down here, didn't I? Hold on. See what I got going on here. So start. All right, that's cool there. Since we did that one, we're in router 3. Let's go to global configuration and just do username. And now this would be R0, password Cisco. All right, do WR. All right, so now they should be able to communicate. And I'll show you what we need to look at. So let's see what we got going on here. Let's maximize this guy so we can see exactly what's going on. We got show start. We have the path that we got the usernames down. We're good to go there. We got our serials coming up. Here's our serial 000. We're good to go there. Our 001 is good to go. Our 010 is good to go. Well, it's not good to go. We have to start there. So config T, interface S0/1/0. And then we're going ahead and going to do encap. Oh my God, I can't type encap. And okay, PPP, and then PPP. See how everything's coming up now? PPP, authentication, chap PAP, do WR. So that interface is done. And the last interface is S011. Okay, so we go to int S0/1/1, and we do encap PPP, and then we do PPP authentication chap PAP. Done. Right? Well, we're done with the middle router and one of the spoke routers. So let's go ahead and go to the outside routers and change their encapsulation. Or did we? Let's check and see. Show start. You guys gotta verify what you've done, because if you got my memory, you don't remember anything. All right, so we haven't. So we have to do the outside ones. All right, so we're in router 1 right now. So we're gonna go to conf T. We're gonna do interface S000. And we're gonna do encap PPP, PPP authentication, chap PAP. And it's gotta be in the same order on both sides. And also, what do you need to do? Username is R0. Password, Cisco. Boom. You gotta do that. You gotta do that. See how it comes up? Everything has to match. Everything has to match. Okay, so while we're here, let's do that in order then. Conf T. All right, we're going to go into int S000. And we're going to, I said we're going to do it in order. So, okay, PPP, or encap, PPP, PPP authentication, chap, PAP. Let's escape out of here. Username, R0. Password, Cisco. Boom, should come up. There you go. We did this one already. Let's do this last one. All right. So let's exit. I'll make sure I'm in the right interface. Int S0/0/0. Encap PPP. PPP authentication chap PAP, and then we'll exit once. Username R0, password Cisco. Boom. Control Z. Done deal. So how do we know that it is actually is working? That the encapsulation did change? Well, show interface 0/0/0, and you will see now one that our encapsulation changed to PPP. And one of the things you want to see is these two lines that they're open, right? Your Internet Protocol Control Protocol and your CDP Protocol Control Protocol. All right, that needs to be open. You get this, you know that you have connectivity, you know that everything is working fine. If you don't see this open and it's closed, then we have an issue somewhere. It could be you didn't create the username and password the same as in the other router, or you're having an encapsulation mismatch where one is HDLC and one is PPP. So these are the things that you need to look at when you're doing your certification, and they may ask you a PPP question, okay? But that's it. That's how you see how simple that was. You put in the username, and I put more routers than they're going to put in there. They'll probably just put 2 routers, and that's it. So that's all you need to look for. Make sure that they have the right type of encapsulation, and they're using authentication. That the authentication, they're both using the same type of authentication, and the password is the same. That's identical, and they're case sensitive. All right, I'll see you guys outside the lab. That's PPP. Okay, not too bad. We're into a couple little things here, right? Like the username and stuff like that. But you see how this hub router had to have the username for every other router, right? And password Cisco. And only this one had one username, which is the hub router, which was router 0. And then everything else was the same, encap, PPP. Then we go PPP, authentication, chat-pap. I mean, it's the same thing over and over again. That's it. And one of the things, and I like to show you here, if you just bear with me for just a second, and I will get out of your way, even though we already looked at, okay, my finger doesn't want to work. And you don't want to look at it, because we did do it inside the lab. Show interface. Which interface? Which router am I in? Oh, router 0. Okay. Which S000, S000, make it simple. S0/0/0. And one of the things that we talked about was that you see the encapsulation is PPP, says it right here, encapsulation PPP, and then you need to see LCP open, IPCP, Internet Protocol Control Protocol, and CDP Control Protocol. You need to make sure of those lines. You may get a print screen that says that. It may say closed. That's an issue. Either the username is not there, or the authentication is not there, or the encapsulation is not there. So you need to see where it's going on, who it's connected to, so you can get that fixed. All right, so you can get the fix. It's going to be the other router. All right, so just make sure that the usernames are there with the correct, and it's case sensitive. You need to see these lines. 1, that the encapsulation is there, and 2, that these 2 lines right here, they say open. But that's it. It was pretty easy. We ran into, like I said, some gotchas, but we got it working because of usernames. But other than that, that's it. I'll see you in the next one. All right, frame relay, old news. Now, the reason, let me explain right off the bat, I'll explain it again when I get inside the lab, is this DLCIs, why is it 102? Because this is router 1, and it's connecting to router 2. That's it. And this is router 2 connecting to router 1. Router 1 connecting to router 3, and router 3 connecting to router 1, and so forth. So I made it simple, that way you can understand what you're doing. And we're making simple subnets. It's a Saturday 30 and 5 and 6. Okay, and then what do we got here? Oh, this is the actual IP address, 9 and 10. All right. Oh, this is 5 and 6. 5 and 6, 9 and 10. And this is 14 and 13. So we got the 4, 8, and 12 networks going on. So all we got to do is go inside the lab and configure the encapsulation and make sure we have the right IP address, and we put the frame relay interface, right? The sub interface, the encapsulation type, and the DLCI number, the correct DLCI number. And then later we got to come inside this big guy and make sure we do that correctly. All right, we do the ISP jobs for them. See you inside the lab. Welcome everyone to the Frame Relay Lab. As you can see in our topology, this is really the preferred method to configure frame relay using sub interfaces. And each sub interface represents a permanent virtual circuit, which is identified by a data link connection identifier, or DLCI, as you can see right here. And that obviously is given to you by your provider. So all we need to do is put in our gateway for our LANs. Obviously, the PCs already have their PC, and then do the encapsulation of frame relay on our interface, and then create the proper sub-interfaces with their DLCIs to be able to connect to the cloud, right, to our provider. And then we'll go inside the cloud itself and configure the serials that you see here, and then the actual frame relay to make that connection from here to here and here to here and so forth. All right, so let's get to it. All right, and just so we can see what we're doing, I'm just gonna make sure it's wide enough. Make it a little bit longer. There we go. Just click inside here. And obviously, I'm going to answer no to that question. So this is going to be router 1. Just config T. Tab out host name, R1. And interface F0/0. That's normal, just a normal everyday default gateway, 192.168.1.254.255.255.255.0. And we'll do a no shut. And then we're going to the serial 000, int S0/0/0. Now here, what we're going to do is we're going to do the incap, and then we'll do frame relay. And then we turn that interface on. That interface obviously needs to be on, but we don't put an IP address there because we're going to create sub-interfaces like we did in VLANs. So I'm going to up arrow till we get to that one. So we're going to give the frame relay a .102. And don't forget to put point to point, or else it will not work. You will not be able to create it. Okay? So you have to put point to point. Then once we do that, we're going to give it the DLCI number. We're actually assigning it. So frame relay interface DLCI, and this is 102. And then the IP address, which is 10.1.1.5.255.255.255.252. Enter. And let's do the other one, which is going to be to router number 3, to the other side. All right, the other DLCI that we have there. And again, it's just the same thing. We create a sub interface. And this one's going to be 103. Okay, change state to up. Interface, or frame relay, I should say, interface DLCI 103. And then the IP address, which is 10.1.1.13. And then 255.255.255.252. Enter. UWR, and then let's do a do show start to take a look at what we have done. Okay, let's scroll back up. And you can see we've turned on the encapsulation frame relay under the actual interface. And then now this 102, or this DLCI 102, just to make things easy in the lab, means I'm connecting from router 1 to router 2. And the DLCI 103 is I'm connecting from router 1 to router 3. So that's just so you can get a better understanding of what these numbers are. But these are the ones that are identified when you go through the cloud to a provider who you're trying to connect to. All right, so let's go down. Let's bring this down. Now let's go to router number 2 up there. Let's bring this over here. Okay. And again, I'm just going to widen this out. Okay. All right, we're going to answer no to that question. Let's make it bigger so we can see much better. There we go. Enable config T interface. Well, let's do the host name, right? Host name R2. And then we're going to go ahead and put the interface for the LAN F0/0, and then IP address 192.168.2.254.255.255.255.0. And then we're going to do a no shut. And that's our normal LAN. Then we're going to go into the interface, which is a 000 as well. And you know, I try to make things simple. We're trying to learn a concept. I'm not trying to confuse you. And then we do the encap, which is frame relay. And then we just turn on that physical interface. Remember, we're creating sub-interfaces. Now here we have two DLCIs, 201 and 203. So that's exactly what we need to do. So let's create a sub-interface, .201, which is going back to router 1. And remember, you got to do point to point. If you don't do that, it won't create that subinterface. And then you're going to do frame relay interface DLCI 201. And then we're going to do the IP address. IP address, which is 10.1.1.6, 255.255.255.252. Enter. Very, very simple. Let's go to the other subinterface, which is going to be 203, which is going to router 3. Okay. And then we'll do the frame relay DLCI 203. Okay, and then the IP address. IP address 10.1.1.9, 255.255.255.252. Enter. And then we'll do a no shut. Well, I'm sorry, the no shut's already there. All right, so let's make sure that we did everything correctly. Let's verify. Always verify. You have plenty of time. IP address 204. Okay, that's the LAN. Here's our encapsulation. There's our DLCI 201, 201, 203, 203. We're good to go. Let's go to the last router now. And again, I'm going to move the lab a little further out this way so we can see exactly what it is we're configuring. We'll put it right here at the edge of this PC. Just make it, make it a little bit bigger. All right, let's stretch it out there so we can see all the commands properly. I'm going to say no. I'm going to enable config T, host name R3, and interface F0/0, IP address 192.168.3.254, 255.255.255.0. And we just do a no shut. That's no big deal. We know that's just a normal default gateway. Now we go to the serial interface S0/0/0, and then frame relay. Encap frame relay. There we go. And now we're going to create the subinterface. In this case, let's do first 302. There's no particular order. Just don't forget point to point. I know I've said it 3 times already, but I'm making it a point to make sure you don't forget. Okay, now we do the interface, the LCI. Okay, and this is going to be 302 going back to router 2. And then we put the IP address. IP address, too many S's there. 10.1.1.10, 255.255.255.252. All right, so let's do the other subinterface, which is 301. All right, take that 2 out, put 1, and then we'll do the interface, the LCI. There it is, back to 1. And then the IP address, which is IP address 10.1.1.14, 255.255.255.252. Enter. Do WR. Outstanding. All right. And again, verify, do show start. And as you can see here, there's our gateway for our LAN, our encapsulation, and both of our serial interfaces, which are configured. Okay. Oh, I didn't do a no shut under the physical interface. So let me go ahead and do that. Let me exit once, interface S0/0/0. I'm doing no shut there. Forgot to do that. Saw that red light on the packet tracer. Okay. So what we need to do next, now that we've done frame relay, now we got to be the provider. We got to go into the actual cloud and make these connections actually happen. All right. But what you saw was the preferred method of configuration for frame relay, especially if you're going to run RIP, so we don't run into a split horizon issue. All right. Every subinterface is its own permanent virtual circuit, and that's what we need to do. That is a preferred method. Sounds like a question to me. So let's go into the cloud. Okay, and let's open it up again so we can see what we're doing. And really here, we don't need that much space. So let's put it right here so we can see the routers. And I'll make it this way. All right, so we go to config. Now we have serial 1, 2, and 3. So we go to serial 1. So serial 1 has a DLCI of 102. And that is a connection to, and this is just a description, from router 1 to router 2, right? So you know what it is. And then we also have a DLCI of 103, don't we? And that's a connection from router 1 to router 3. And we add. So we're done with serial 1. Now serial 1 knows, and remember here, make sure that that's on. And the LMI, meaning the signaling method, is Cisco. This is using Cisco routers, is what's preferred. All right, so we're going to go to serial number 2. All right, serial number 2 has 2 DLCIs as well. We're going to have 201, which is a connection from router 2 to router 1. And we add. And then we have 203, which is a connection from router 2 to router 3. And we add those. So right now the provider is just getting information, what's going on the interfaces. And that was serial 2, as you can see right up here. So now we go to serial 3. Serial 3, again, we have 2 DLCIs. We have 302, and just so you can see it, because I don't think you can see it, there you go. 302, and tab over it. That's a connection from router 3. And remember, this is description. Router 3 to router 2. I'm going to add that. And then we got 301, which is a connection from router 3 to router 1. So now we have all the connections that we know of, right? The ISP, right, says, okay, these are all the connections that exist. There's nothing on serial 0, okay. So now let me go to frame relay. Here, we're going to go ahead and make the connections. So we can go from router 1 to router 2, router 2 to router 1, and router 1 to router 3, and so forth, all right? So let's start creating those connections right now. So in serial 1, which is the first one that we have, where there you can see right now automatically there is a connection from router 1 to router 2. And on this one, I'm going to pick serial 2. That automatically brings back a connection from router 2 to router 3. So we're going to click add. So what we did was we said, hey, connection exists from here to here and here to here. All right, let's continue with serial 1. And let's make a connection from router 1 to router 3, which means this way. So then we're going to go to serial 3, which there's a connection from router 3 to router 1. Oh, okay, so let's add that. So now we created a connection going this way. So all we got left really is to make this third connection from router 2 to router 3 and back. So we're going to pick serial 2, and we're going to select router 2 to router 3, and then we're going to get serial 3, and then router 3 to router 2, and we're going to click add. So now we have connections going all the way around. We have a connection from 1 to 2, 2 to 1, 1 to 3, 3 to 1, 2 to 3, and 3 to 2. Awesome. All right. Oh. Click the wrong one. For whatever reason, my brain thought it said save. All right, so we're just going to minimize that. Now, what we're going to do is I want to run a routing protocol because I want just not to be able to connect to the routers. I want to be able to connect to the end devices. So we're just going to use RIP because this is the preferred method when you are doing RIP, all right, to do so. So we're going to enable config T, router RIP version 2, network. We have a 10.0, remember, class full, network, 192.168.1.0, and then no auto summary, do WR, minimize that, go to this router, do the same exact thing, enable, config T, router RIP, if I can spell router correctly, version 2, network 10.0, and I believe that is the 2 network for the LAN, if I'm not mistaken, and I'm not. So we go net 192.168.2.0, no auto summary, do WR. And again, you know you guys can't do WR. You have to go ahead and go back to privilege mode and do copy and start for your certification. All right, and then we'll go to the last router. We'll maximize this one. We'll work from right here. All right, enable, config T, router RIP, router RIP. Trying to find a new spelling for router. Should put a spell check on this thing. Network 10.0, network 192.168.3.0. and then no auto survey. Okay, so if everything is working together, we indeed have connectivity, we should be able to see our routing table, and we do. So instead of pinging from the router, which we know we can, let's see if we can actually ping from a PC. So let's open up this PC over here. We'll just put it right over here so we can take a look at our topology. And we're going to ping 192.168.1.1. And obviously, use IP version 4. We got to wait for that ARP. I know I can hit that fast forward, but we usually want to see that happen. Okay, connectivity. And then 2.1. Again, wait for the ARP. But the interesting thing is we're going across a cloud that's configured with frame relay. And there you go. That is what frame relay is. And again, I want to drill this into your brains. This is the preferred method. And let's bring this one that's maximized. This is the preferred method to configure frame relay. So if you get print screens or questions or what have you, which is the preferred method to avoid split horizon, this is it, because you're creating sub-interfaces, which are the PVCs, the permanent virtual circuits, and each PVC has its own DLCI, data link connection identifier, that will actually talk to the provider and say, hey, this is who I need to go to. All right, and you have the IP addresses there. This will avoid split horizon if you're using the RIP routing protocol. There's your frame relay. I'll see you outside the lab. Okay, not bad. Made a lot of typing, but again, you got the gist. The biggest thing I think afterwards is going in here, okay, and going into the configuration, going into each serial, putting their DLCIs in there, right? And giving it a description. Hey, this is going from here to here, and then going to frame relay, and then let's see if my finger works good. No, of course not. Let's open this up, and you're making the connections. You're saying, hey, serial 1 is connecting from, okay, R2 to R1, serial 2 to serial 3, R3 to R2, and serial 1 from R3. On R3, serial port 3, from router 3 to R1. This right here is what's making those connections. This is saying, hey, we're having this connection, and this connection. And then we did the RIP routing protocol to make sure we can ping across to the PCs, and we did. And that, ladies and gentlemen, is frame relay. See you in the next one. Welcome back, everyone. Now, as you can see, there's many ways to go across a wide area network, right? But we can also do GREs. Let me get on this side. GREs, okay? GREs. So this is going to be a little lab that we're going to do. We're going to talk about a little bit first. So what is a GRE? It stands for Generic Encapsulation Tunnel. It's great because it can encapsulate any routed protocol, any router protocol. It can go ahead and you can use it with GRE. The bad thing is that it's plain text. It's plain text. So if you want to secure it, you're going to have to use IPSec on either side of the tunnel in order to have security. Now, DMVPN uses GRE. In that case, you can use one single GRE or multiple GREs when we're doing DMVPNs. All right, in that particular design. But it's a pretty, like I said, it's right there's a pretty straightforward configuration. I'll show it to you now. And again, this is an example. I may not use the same IP addresses in the lab, but I'll try to. You know me, I forget. I try to. But this is it right here. Okay? You create the tunnel. This is the physical IP address. Okay? This is the tunnel source. This is the tunnel destination. The IP address of the router itself. This is the tunnel source, tunnel destination. Done. Done. Okay? So with that said, let's get inside the lab and let's get this done. All right, welcome to the GRE lab. As you can see, it's going to be a very simple, basic lab. There's only 2 routers, point to point. All right, the network is going to be the 172.16.30.0 network. Okay, that's going to be the actual network. So let's go ahead and put those IP addresses in there. Since it's a small network, I don't mind doing this. even though should have been in there already, but okay, no problem. All right, config team, interface. What interface is this? Is this the top of it right? No. S000. 000 is the first one. Okay. S0/0/0/0/0. This is why I like to have things ready. I'm teaching you a concept, not how to put an IP address. IP address 172.16.30.1, 255, 255, 255, 252. No, okay, clock rate. It's the serial, forgot. Clock, can't spell clock. Clock rate, 4 million. All right. Unknown clock rate, I forgot 10. Always keep forgetting my own paycheck. I can't believe that. No shut. All right, that's the only interface as far as physical interface that I'm going to configure, but I'm going to configure my tonal interface. I'm going to go interface, tonal, but why even do that? Let's do it quickly. Here we're going to do interface tonal 0, put an IP address for the tonal, okay, and the mask, and then we're going to go ahead and copy. The source is serial 00, and the destination will be the IP address on the other side. All right, so I'm going to copy, and then paste. Do. Done. All right. Do WR, do show IP in brief. Take a look at that. And you see that the tunnel 0 is right there. There's the IP address that we put. Obviously is up down because the other side is not done. Okay, so let's go to the other side. And let's do the exact same thing. All right, let's do the exact same thing. Say no, enable, config T, and we will interface S0/0/1, IP address, and that's going to be 172.16.30.1. No, sorry, .2, 255.255.255.252. Yes, no. The physical interface. Sorry, 192.168.1.2. All right, 255, 255, 255, 252. All right, no clock rate needed here. No shut. And then I'm just going to copy paste. You see, this is why I don't like to do it this way. Interface S0/0/1. I was right the first time. IP address 172.16.30.2, 255, 255, 255, 252. Enter. No shut. Okay. DWR. Let's copy that. And now we can copy paste. Copy and then paste. Boom. Tunnel, change state to up. Do WR. Let's do a show IP in brief. Let's get rid of all this gibberish. Show IP in brief. All right, so our tunnel is up. Can we ping it? Ping 192, not 992. Ping 192.168.1.1, and we can ping the tunnel. So that's what you call a GRE tunnel. It's plain text. It's not secured unless you configure IPsec, but that's not what this lab is all about. So that is creating a very basic GRE tunnel. See you outside the lab. All right, and we're back. That wasn't so difficult, was it? It was pretty simple. This is a configuration we actually did. We didn't use the MTU 1476. That's something you can omit or you can put it in there, but we didn't use that one. Okay, all we did was put the IP address of the tunnel. Okay, not the tunnel. The IP address of the tunnel. The source on one router is the serial, the actual physical interface, and then this is the IP address of the actual interface. And then the same thing goes for the bottom one. Okay, that's all it is. That's all it is. You can get basically you're making sure you have connectivity, and then you create your tunnel interface. That's it. That's it. And then you tell it, obviously, the tunnel destination. You got to give it a source and a destination. Okay. But that's all there's to creating GRE tunnels. Very basic GRE tunnels. We didn't have any IPsec configured in there. You don't have to worry about IPsec. In the real world, you do. In the real world, you will configure IPsec if you're creating, if you're creating GRE tunnels. All right. So, but that's it. That's all there's to it. You saw it working. You got connectivity across your tunnels. Not a big deal. Not a big deal. I'll see you in the next. Welcome back, everyone. Well, now we're going to talk about radius. What is radius? Now, we know what radius is. Radius has been around for a long time. We use it every time we're doing Microsoft. And then when we took wireless, we saw that we can have a radius server to authenticate all wireless clients. And, we get everything. It can get very complex because then we can have certificate of authorities and all sorts of craziness going on. But what it is just a remote authentication dialing user service. That's what it is. That's what radius does. All right. And we can do this on a Cisco router. So we can actually have our clients, our wire clients, with username and password, and the radius creates a database of these particular users. All right. So you create the commands, which we will do in the lab. You should use those commands. You can use it for telnet. We'll be using it for telnet mainly. Where when the client tries to telnet, it's first, what's going to happen is it says, well, wait a minute, are you authorized in this particular LAN? And if you are, then we're going to go ahead and you have to put in your credentials, because you will put in, let's say, like I put in Laz and then Cisco. That's what you would use, or what have you, Bobby, and then, tomatoes. I don't know. You will put in a username and password. Okay. So that's what radius does. It actually authenticates your users in a central, like it says right here. Having a central service also means that it is easier to track usage for billing and what have you. But you can read this on your own. The broken down version of this, yes, all it is a centralized server to authenticate your users. That's it. That's it. Or you can do it for devices as well. Okay. Now, specifications on it, protocols and ports. Obviously, we can use UDP 1812 and 1813, or UDP 1645 and 1646. You can do encryption. All right. Encrypts only the password field. Only the password field. Authentication and authorization, it combines both. All right. Because you'll see it when we start doing it. And then its primary use is for network access. That's it. That's what radius is to allow somebody network access to your network. All right. They're being authenticated. It's just like when you log into Active Directory, right? When you log into Active Directory, you log into a particular domain. So who's authenticating you? It's going to the Active Directory server. It's saying, hey, is this user a user on this particular group? Depending on the group that you are, then permissions are based on that particular group or that particular user. You shouldn't do it per user, you should do it per group. But regardless, we're not talking about Microsoft. But it's essentially the same thing. You have one centralized database, all right, that's going to hold all your user accounts, remote or local, and it's going to go ahead and keep track of them and what they're doing. Okay, well, not what they're doing, but they've logged in, they've logged out, they use Telnet, they use SSH, whatever it is that you configured it for. Okay, and then you put the users that you want. If you're not a user in that database, you ain't going nowhere. You're not even going to ping the network. Okay, but enough said. That's what the radius is. Let's get to the lab. All right, now we come to radius server. Now this is something you don't do at home, unless, I don't know, you got nothing better to do. All right, you don't have a radius server at home, but you do have a radius server at an enterprise network, at a medium-sized company. In a small company, if you want some security, you want to make sure that people are being authenticated, right, into your network. All right, so we're going to go ahead, and you see the configurations right here, and we'll explain to you as we go along. All right, one of the first things we're going to do is put the IP address, obviously. Whoa, okay, the router just booted. Okay, nope. Let's get all this gibberish out of the way. We got to put an IP address. Let's put a host name on here. Enable config T, host name R1. Okay, int F0/0 IP address, two S's, 192.168.1.254, 255.255.255.0. No shot. All right, PWR. And let's minimize this. So let's just get this out of the way real quick so I can fast forward because this takes way too long to turn green. Okay. All right, so I'm going to ping 192.168.1.1. That is the radius server. All right, I'm going to ping the PC, which is 1.2. So we have connectivity. All right. So what we're going to do is we're going to go ahead and create a AAA authentication model. All right, for people to be able to authenticate to the radius server in order to have access to the router in this case. All right, so you can see it right here. It says AAA new model authentication for the login default group for the radius, because you can pick radius or TACACS, is none. And we'll type it in instead of copy pasting. I won't be that lazy. All right, so be careful with your spelling. AAA new model. All right, so if you're typing in caps and all that good stuff, this ain't an English class. Don't worry about grammar. Keep it all lowercase. AAA authentication. I'm going to tab it. Okay. Login, because my spelling is horrible. Default. Group. Radius, because you can pick radius or TACACS at this point. And then none. So the default group, we're not going to have any authentication. AAA. Authentication. Tab it out. No, not yet. Tab it out. Not yet. Authenticate. Come on. Oh, I misspelled it. That's why. You see? You see? Authentication. Login. But now for the telnet underscore lines, because there's many lines. Okay. Group. We're going to go ahead and do radius. Okay. AAA. Authentication. Login. You see I spelled telnet lines wrong. You see that, right? You see? You know what? We're not going to do this because we have to say no to that, because it'll cause an issue later on. Copy. Paste. As a matter of fact, this is what we're going to do. Do erase start. Because you do one step wrong here, and it just won't work. I don't know if it's the simulator or whatever it is, but let's get things done right. The commands are right there. This is why this is booting up. The AAA authentication new model, all right? And then the default group, the tunnel lines, and the console. So anybody trying to tell them the console in, it's going to have to authenticate to this particular router. All right, so let's go ahead and do that. Let's type the host name again. Host name R1. The IP address, int F0/0. IP address is 192.168.1.254, 255.255.255.0. No shut. Okay, PWR. All right, so that's done there. Let's exit. All right, so we have, and yes, we're going to do this. We have a AAA new model. We're going to do for the default group, no authentication, radius for telnet, people who are telnetting, and radius for people who are trying to console in. So we're going to copy, and we're going to paste. All right, so that's what that does. Now this part right here, radius server host. Who is the radius server host? The radius server, which is 1.1. Using port 1645, and we need to put a secret key. So we put Cisco secret. All right, so we're going to go ahead and paste that in. Also in privilege mode. There we go. And then just a line count 0. We got to tell it, okay, since we put telnet lines, console lines, okay, so we got to tell it, hey, accounting, exec, console line, and login authentication, telnet line. So we got to put this in right here. So that takes effect on those particular lines. Copy, paste. Okay, done. We're still going to verify if there's any duplicate commands, because if not, it will cause an issue. Right, to make sure that it is done. All right, so we got, there's a default group, the telnet lines, the console line, cool, AAA new model, the host name on the router. All right, the host, now you see the host, here's the IP address. There's a host 1.1 with the correct port and the Cisco secret. Awesome, so that's the part of the router. The part of the radius server is, we go to AAA, it's off by default, let's put it here. It's off by default, we turn it on. What's the client's name? R1. Let's verify. Because I don't trust myself anymore. R1, yes. R1. Okay. So what's the IP address of the client? 192.168.1.254. That's the IP address. What is the secret key? Cisco secret. And we're using radius, not TACACS. Okay? So we're going to add Cisco secret. Make sure the spelling is correct. You add that. Now the username is going to be Laz. And the password is just going to be Cisco. It can be whatever you want. I'm just going to put Cisco. All right, so let's see what happens. Let's go ahead and go to PC. Let's bring it over here. Let's try to telnet into our router. Telnet 192.168. What? 1.254. I never put any username or anything like that. All I did was login authentication telnet line. So it's using the radius server to authenticate. The username is Laz. All right. The password is CISCO. Okay. So now it's going back and forth, talking to the radius server. Say, hey, who is this guy? Is he authenticated on the network? Do you know? Do you have him? Yes. Cool. Now I'm in the router. That's what radius does. It authenticates. I mean, it does a lot more than that. You can really get complicated configurations. For CCNA certification, this is the basics. This is what you need to know. Radius is used for authentication, okay? And this is one way that you can do it, especially for the telnet lines, all right? That telnet is plain text anyway. You can use radius for anything. We use it in wireless. I use it in wireless as well. We authenticate wireless users on the radius before they can get access to the access point to get onto the network. And that's exactly what we did here. We actually said, okay, let the radius server authenticate you as a valid username or a valid user, and then it asks you for the password. It exchanged the secret keys with the router. The router said, is he valid? Yes. Okay, well, let him in. And boom, I'm in. That is what radius is all about. I'll see you outside. Okay, that wasn't so bad. That wasn't so bad, right? We did our AAA authentication login. You see they're both the same. We did it for the default groups. We didn't put any authentication there. But for the telnet lines, we're telling it to look at a radius server. And we do accounting, all right, on the console line to start and stop in the group radius. But more importantly, this is where everybody gets messed up, is what IP address do I put? Okay, when you're doing the radius server host, you gotta put the IP address of the actual radius server. And then which port that we're using? We're using port 1645, the key, and then the actual key that we're using. Some people think they don't know who to point it to, and that's the problem. But that's it. You're not gonna be configuring radius, okay? Just know what radius does. All right, and the ports that it uses and stuff like that. You can create passwords and what have you. And it's a AAA authentication, okay? But here it is right here. And then you saw what we had on the very top. Where it is right here. You saw what we had on the very top. It said accounting for console lines, because that's what we put on top. And then login for authentication in telnet lines. Telnet lines, okay? So this is how you would do radius. You saw that it worked. Then we got our little PC2 here. And we didn't put any username or passwords on the router. So it prompted us immediately when we telnet for a username. So we put in Laz, right? Because if you go to the server and you go to services and you go to AAA, you see that we have Laz and Cisco. So that's what we have to type, Laz and Cisco. But you can see here the client. Who's the client? It's the router. The host name of the client, R1. What type of radius? And then the key you add it. That's it. That's all there's to it. Now, obviously, this is simplified here in the packet tracer, but that's the essential. Oh, please remember, turn that on because it will be off. Make sure that it is on. Okay? But that all in that, you should be good to go. Good to go. All right. And then you saw that the lab worked. No issues. No issues whatsoever. That is radius. See you in the next one. Welcome back. We just came from radius. Now we got to do TACACS. Yes, it's a weird name. TACACS Plus, that is, because that is the enhanced version. All right. It's pretty much the same thing. You can read about it for all you RFC freaks on 1492, all right, to get all the last things. But it runs on TCP. That's one of the advantages that it has over Radius that Radius uses UDP. This is using TCP. It's still accepting username and passwords. It's still authenticating users, all right, to the network. Obviously, it's based on algorithms and the data used to make decisions to complete control whoever is running the TACACS daemon, which is also called. All right, but definitely TACACS is pretty much the same configurations. Instead of putting radius, you put TACACS. All right, but again, the differences is definitely it runs on TCP, which is connection oriented. And more importantly, with radius, the encryption is only the username and password. With TACACS, everything, the whole data is encrypted, which makes it better. So it has less vulnerabilities uh, than Radius, because Radius it's open, it's open to a lot of attacks due to the fact that it's running UDP and not everything is encrypted. But you're gonna see now in the lab is pretty much the same configuration. What we're gonna do again, this is the very, 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 very basics of these two protocols that we did. We did Radius already. Now we're doing TACACS, which is pretty much the same thing. Pretty much the lab is going to look the same. IPs hasn't changed or anything like that. It's the same IPs. So let's go ahead and get into the lab now. Welcome everyone to our TACACS lab. As you can see here, we have our TACACS server. That's going to be 10.2. And we have our client, which is going to be the router itself, which is 10.1. And we have a host here, so we can go ahead and we're going to telnet into 10.3. But I'm going to move this to one side. I don't know why it did. Why did that move that way? There we go. And open this up. There we go. This is the commands which you will have access to, all right, that you need to do in order to create. Now, obviously, you don't need this. You just need to put whatever IP address you feel like it, but I'll have it there just so you know what to put in case you can't see it there on the lab itself. And you can see the TACACS host, it's going to be 10.2. The TACACS server host, 10.2, Cisco secret. I put it twice. I don't know why. Let's delete one of those. I don't want you to think, oh, hey, last put it in twice. All right. So this is the commands that are in here already. All right. I'm not here to show you how to put IP addresses on interfaces or anything like that. I'm here to show you the commands that you need to type in. Now, what we did was we created a new AAA model, and this is obviously done from global configuration. This is done from global configuration. We do a new AAA model. We do a AAA model for authentication login for the default group. Instead of using Radius as we did before, we're going to use TACACS Plus. All right, we're going to do the same thing. We say none. All right, and triple authentication login for telnet lines. Telnet lines. All right, for that particular group, we're going to use TACACS Plus. All right, you can put whatever IP address you want. It doesn't matter as long as it's the correct one. All right, within your subnet, within your network. Okay, and then the TACACS server host is your actual TACACS server, which in this case is this guy right here, which is 10.2. And I'll show you how to create the secret key. Not a big deal. Then you go to your line BTY 0 through 4 or 0 through 15, whatever it is that you're using, whatever allow you to put. And you put login authentication. What are we authenticating? Telnet underscore lines. That's what we put up here. We need to match this guy right here. So these are the commands that are in here. I'll show you now. All right, so this is a command. You're going to have access to this particular text file. All right, so the commands will be there for you. You don't have to think much about it. Let's go ahead and move this to one side. And let's do a show start. All right, there is your new, yes, I do have a secret password in there. I don't know why. That way you can get all the way into a router, because if you don't, you can't get in all the way in. You only be in user mode. All right, but here's your AAA new model. Here's your authentication for both. One for the default group, one for the telnet lines. And you keep scrolling down. You're going to go through the interfaces and what have you. And then you get to the TACACS server host. This is key. Ha, that's funny. This has to be the same, okay, when you're doing it on the server. This is what they need to authenticate to each other, okay? And then on your line, BTY lines, you would put the login authentication telnet lines. All right, so let's take a look at our server, all right? And again, we'll just put this off to one side. We'll go to services. We'll go to AAA. As you can see, here you put the client name. Who is your client? Router 1, which is this guy. What is the IP address? Or it's our default gateway, 10.1. Well, what do you want to use, Radius or TACACS? We chose TACACS for this particular one. And the key, we always use Cisco secret. All right, and then we just click add. We can add that in there. Now here, I decided to add two different usernames. We had a user, Cisco, and I put Laz Cisco. So we have two usernames, because one of the things that I want to show you is AAA accounting, how it's going to go ahead and get that information. All right. So let's go ahead and try this. Let's see how this works. Did I do that? I don't know. Okay. Let's go ahead and telnet. All right. Telnet. And it's 192.168.10.1. And it's asking me for a username. Now you see I didn't create any usernames, and I didn't say login local or anything like that. This is actually saying, hey, I'm trying to authenticate to the TACACS server to see if you really exist. So let's pick Laz, and let's put in Cisco, CISCO. Oh, did I put the right one? Yes, I did. Enable is Cisco again, and now we're in the router. Awesome, that worked. Okay, so let's get out. So now let's try to do it again. Let's up arrow. We're going to telnet again, but this time we'll put user, and then we'll use Cisco. Oops, I put in the wrong password, CISCO. Okay, and now I'm in. Enable, password is CISCO, and now we're in. That's what it's doing. It's authenticating with the TACACS server that we indeed actually exist. And we can verify this in a AAA accounting. Now you can see I've done this earlier. Okay, but you can see here, Laz, okay, and you have then user, okay, it's using the username user, okay, so it has all that information. Who am I doing it to? I'm doing it to the 10.1. So it keeps a date stamp, a time stamp of, who is accessing the router, all right, who is accessing the router. So that's good. That's what TACACS does at its basic form. You can do a lot more. But for CCNA certification purposes, this is all you need to be really concerned about. And again, you will have access to this particular text file, which is all you need to do that particular configuration. Now again, this right here, we all know we need an IP address on that interface right there. Do you have to use the same interfaces IP addresses that I have? No, you can make up your own subnet. Just make sure you're within your own subnet, okay? That's not going across anything else. I mean, not that it couldn't, it could, all right? And make sure that you're pointing to the proper server, and that the server and the secret on the router and the secret on the server, meaning the key, is the same. It is case sensitive. So be very, very careful. You're not in English class, okay? So make sure that you put things correct. But that's it. That's all there is to TACACS. I'll see you outside the lab. All right, and we're back from our lab. Pretty easy, not bad, straight to the point. Okay, here's your TACACS server where we did. Here's the client. Here's the IP address. We're going to use a TACACS server, and this is the key that we're going to use with the Cisco router, which is Cisco secret. We added those two names, right? So we can authenticate, so we can be authenticated to the TACACS server. We had the user account, and we had LAS. Okay, then we can go ahead and telnet, because everything was done to the telnet lines on the actual client. Remember, this will be your client, the 10.1, and this will be the host, right? So when you're doing your configuration, you're a AAA new model. We're doing authentication login for default. Group TACACS, none, as usual. AAA authentication login. Telnet lines, that's what we're doing. That's why I said line BTYs, okay? Group TACACS plus the TACACS server host 192.168.10.2. That's the TACACS server host 10.2. Okay, and then you go. The key is going to be Cisco secret. They must match, so it is case sensitive. All right, it's got to be the same, exactly the same. All right, and TACACS server. I already told you that. I wrote it both wrong. Okay, I put it twice. So sorry. I put it twice. Okay, and then line BTY 04, and then we have our login authentication telnet lines. Just make sure. I mean, you're not. Again, I'm repeating it a million times. Doubtful. I'm gonna say it that way. Okay, doubtful that you guys will be doing this, because this really falls more under the branch of CCNA security than anything else, not the CCNA routing and switching. But at least Cisco is a good thing. They want you at least to be aware of it. That's why more than likely this will be a multiple choice or multiple response question. Or maybe it could be, drag and drop or what have you. So just understanding the concepts of TACACS and what it does is more important than anything else. Real world, definitely you need to know this. You will know this. You need to know in a lot more detail. This is like the very, 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 very basics of it. So you will need to get into detail if that indeed is what you're going to be handling. Because when you go to the real world, everybody has a particular thing that they're going to be doing. Are you handling the WAN side? What part of the WAN side are you handling? Are you handling the LAN? And what part of the LAN? What aspect of it? Unless you're the only IT individual in that entire company. Because if you're using a TACACS server, I'm pretty sure you're at least a medium-sized business, and there's more than one IT person there. There should be. If you're the only one, I'm sorry. I hope you're getting paid for it. All right, because there is a lot of things to TACACS or Radius or any security that you're going to do, because you have firewalls and policies and all these different things, switch port security. So it's insane. But anyway, this is how you would configure TACACS. And this is the policy you went on. Don't get confused. This is your client. This is your host. The secret key needs to match, and it is case sensitive. That said, you saw it done. Easy peasy. See you in the next one. All right. IPSLA. Very interesting that this is in the CCNA. And everybody's going insane with it. Okay? Stop. All right? Because if you see a question on it, wow. Okay? But we'll do it anyway. All right, so IPSLA. It's a feature that measures the ongoing behavior of the network. All right? All IPSLA does is it monitors your network. It makes sure that the packet that it's got there, that you're getting in response, like it says right there, gathers information. Here it says about delay and jitter. Obviously, you need to configure something like that. Okay, but primarily acts as a tool to test and gather data about networks. Okay, then a network management tool can collect that and report whether the network reached SLAs for the network. Okay, that's all an SLA is. Now, in the book, Tom Lamley, okay, or Cisco Press. It's about a page and a half. Do you honestly think that IPSLA, with all the features that it can do, it's going to be a page and a half? No. So what does that tell you? First of all, the Cisco Packet Tracer doesn't support it. That's number one. All right. So we're going to be inside GNS3. That's right. So there's not going to be any other routers that you know, which the iOS is going to be different. Which, okay, well here we'll come back to that in a second. The commands that I'm going to give you, yes, they're from the book. Okay, these are the ones that they want you to know. Hey, I want to create an instance of an IPSLA 1, and you know what? The SLA, we're going to do ICMP echo, and this is the one we're going to monitor, and we're going to use the frequency 10. All right, why did that prompt change? Because you're using ICMP, so now it knows you're in echo. And then we go back to global and we say, well, the IPSLA schedule, okay, for that number one, all right, the life is going to be for life, forever. And when do we want it to start? Now. I can tell you right now, that's not going to be the commands inside. These commands stay the same. Well, somewhat, because you got to put, you'll see when you get inside the lab. All right, it's a little different. All right, but again, they're not going to put a specific router up there just for you to do this, because every router's iOS will be different. It will. If you're using viral, they have the XR iOS is in there. So if I do an IPSLA in there, woo, you know. So don't get all crazy on this. All right. Edge-to-edge network availability for monitoring, network performance monitoring and visibility, troubleshooting basic network operation. Doesn't that sound a lot like a SolarWinds tool that we monitor our network? A monitoring, like remember when we did SNMP, okay, that we were monitoring, or syslog or NetFlow, and all these things that we monitor through third-party softwares. Can you create IPSLAs, your IPSLAs? Yes, you can use IPSLAs for many things. All right, to even control routing. Okay, so, but they want you to know, hey, you can use this to monitor your network. Okay, so when we get in the lab, all right, it's going to be slightly different than these commands. And I'll mention it again in the lab. It's going to be slightly different because we're in a different router. We're in a 7200 series router that uses a totally different iOS. But the concept still remains the same. All right, this is why I'm telling you, highly doubt it that you're going to get a simulation for you to go ahead and do this. One thing I said in my now 16 or more years, okay, of teaching Cisco, all right, especially the CCNA, if it's not in the packet tracer, if the packet tracer can't support it, I highly doubt it that it's going to be a simulation. There may be questions because the book has their review questions. The book has paragraphs that you need to read, okay? They may ask you a question about that. Other than that, nope. All right, so enough said. Let's go inside the lab. Welcome to the IPSLA Lab. As you can see right off the bat, we are not in the packet tracer. We are in GNS3. So we're not using any of the routers that exist in the packet tracer. We're using a 7200 series router, which is going to have a different iOS. So let me give you a little warning right off the bat. The commands that we talked about earlier before we went inside the lab, those are true commands, but for that particular iOS that the book is using. Here's going to be slightly different. So if you're running viral, let's say, and you have a different type of router, an XR operating system, iOS, you may not type IPSLA, you may have to type a little something different. So every iOS has its own little glitch or its own little thing that you have to do, but the concept remains the same. So what do we have here? We have the 10 dot network, and let me show you. I'm going to go into the console of router 1. All right, as a matter of fact, let me increase the font size because this is just way too small. Where is it? Where is it? I always lose that. Do I keep passing over it? Change settings here. Change settings. Okay. And we go to all parents. And we go to change font size. And we're going to make this 16. I think that should be good to go. Apply. Hey, look at that. Now we can really see. All right. Let's do a show IP int brief. All right. Oh, I thought I had put that in there. Okay, so let's go put in the IP address real quick. Config T. Okay. Interface F0/0 IP address 10.1.1.5 255.255.255.252. Then we do a no shot. All right, do WR. So let's do that on the other one as well. Let's get the IP addresses out of the way. And we console in. Well, let's change. Can we change the names from here? I have no idea. Okay, console. Let me go here. Let's change the settings to 16. Windows appearance. Go to change. Go to 16. Click OK. Apply. Lovely. Now I can see it, and I'm sure you can. So we're gonna go and what interface is this? F10. F10. Show IP in brief. Let's take a look. F10. Okay. So we're gonna do config T. Interface F1/0. IP address 10.1.1.6 255.255.255.252. At this stage, I don't think I need to explain why that's the IP address. If I do, you're in a world of hurt. Okay. I'm going to ping to make sure I have connectivity before I do anything else. And remember, it's a fast Ethernet. We can always miss the first ping, right, because of ARP. But we have connectivity. That's one of the things you want to first do. Make sure you have connectivity before you start doing anything. And listen, I doubt that you have to configure any IPSLAs, all right, in your Cisco certification. All right. And if you do, please follow the guidelines of the book. It's the concept, okay? We're in global, so we gotta do look. Book says IPSLA 1. Oh my God, it's not working. Okay, well we have a question mark. Real world. Oh, you want me to type monitor? Okay. Then what? What is that I'm trying to do? What is it we're doing? Okay, let me see how we. Oh, IPSLA. I'm monitoring a number 1. Cool. So I'm in now IP config SLA monitor. What am I monitoring? Well, I'm typing. I'm a type of something. I'm trying to monitor something. Oh, I'm trying to monitor echo. Oh, okay. Echo what? Oh, the protocol. What protocol? I would just think it would be ICMP, but it's not. It's IP, and just exactly like it is there. ICMP echo. Okay, anything else I need to type in there? Oh, look, the host name. Who? Or the IP address. Who am I monitoring? Well, I'm monitoring 10.1.1.6. Okay, anything else I need to type in here? Oh, my source IP address. Okay, IP, and it's not even spelled out. Okay, what's my source IP address? 10.1.1.5. Is there anything else I need to type in here? Nope. That's it. That's all I needed to type. So what we typed was just that, right? What we're doing, right? Who we're monitoring the echo, ICMP echo protocol to 10.1.1.6, which is router 2, from 10.1.1.5, which is router 1. Now, it also says that we can do a frequency, but we need to do the frequency from global configuration. Okay, so we go exit. Okay, so we're going to go IPSLA monitor. Oh, remember that one? Monitor one. Well, not monitor one. Monitor. What are we monitoring? Okay, let me see. Oh, no, that's for schedule. Let me see, IPSLA. Go here. Oh, no, I said, did I do frequency already? I think I did. I did the frequency, right? Did I? Or didn't I? I'm looking. Oh, should have done it. Okay. Control C. Let's go back to IPSLA monitor 1. And then we're there. There we do question mark. And there you'll see frequency. Right? Frequency. And then we question mark again. We go number and we just do, whatever, 10. Then we go to global configuration and we do our schedule. All right, so our schedule is going to be IPSLA. Can we just go schedule from here? Nope, we got to monitor. And then, schedule. There it is right there. Schedule what? Give me an entry number. Oh, 1. That's the one we're doing. Right? It's like a process ID number, if you want to call it that. Okay, well, what type of schedule? Well, this is for life. Okay, so this is going to be for life. All right. And then, is it forever? Of course, this is forever. It's for life. Okay, what do you want to start this? Well, the start time is going to be what? It's going to be now. Okay, so everything's pretty much the same, except we had to put monitor, then schedule, then who? 1. All right. And that's it. Okay, so remember what we said that IPSLA is for. It's for troubleshooting, right? It's for troubleshooting, making sure they have visibility to the destination and all that good stuff. All right, so let's see. Let's do a ping minus T. I think it's minus T. 10.1.1.6. I was getting backwards. Yeah. Ping 10.1.1.6 minus T. I guess they don't like it here. Okay, so I'm just going to ping 10.1.1.6. Okay, so we pinged it. Now we can do a show IP SLA. Now, are we going to do 1? Can we do that? No. Monitor. And what do we want to do? We want to look at the configurations. Configurations of what? Of number 1. All right, and there they are. It says, okay, this is IPSLA monitor. We have an entry number of 1. The type to perform is echo. The target is 6. The source is 5. The size of the packet is going across 28. It's so many 5,000 milliseconds. So you can read it right there. Okay, what it's giving you. Okay, it's giving you a whole bunch of information. And you can also do, all right, you can also do a show IPSLA statistics. Am I typing? Statistics. Okay, cool. Oh, no, that's right. You see, show IP. Monitor. Yeah, can't forget monitor. Show IP. Oh, not that. Show IPSLA. Monitor. Question mark. Statistics. For who? For 1. And then it gives you, it says, hey, number of successes, 13. Latest operation return code is okay. Latest operation start time, it was 11:31:40, whatever. All right, so it tells you. So this is cool, all right, because you can monitor your network, making sure everything is okay, all right? But not all routers are equal. If you're the luckiest person on earth, and you're given to configure an IPSLA in your Cisco certification, then please follow the directions in the book. Which book? The Tom Lamley book? The Cisco Press book? Sure, book you're using. Whatever it says there, that's what you type. Okay? Because Cisco is not going to go and pull a number and says, ha ha, we're just going to give them some weird iOS so they see if they can figure it out. No, this is what you do. This is troubleshooting. All right, because when you go out there in the real world, you may get a 7200 series router or an XR iOS. All right, guys, let's see what iOS we're running here. Show version. Where's the iOS? What iOS go? Oh, it's like a. We're running C2700, JK9S, and version 12.4, blah, blah, blah. Whatever the case may be. All right, so we're not running the normal everyday iOS that we're used to. That's why you see that it's different, but the concept still remains the same. All right, so yes, we had to type in monitor, which your book doesn't say monitor, but that's what we're doing. And what are we monitoring? We're monitoring echo. And you saw that weird IP, uppercase echo and all this other stuff. You had to put it. All right, but you still look at your configurations for one, right? That particular entry. All right, and then you still look at the statistics for one. So you can see if you got any return codes, you got any number of successes and things of that nature. All right. So don't freak out just because it's not identical to the book. The concept is the same. This is configuring an IPSLA in a C7200 series router using this particular iOS right here. If you don't have that and your iOS is completely different, you may simply just type what's in the book and it'll work just fine. And that's fine for the certification. Just understand what this is about, what IPSLA is about. When you go to the real world, you may not be running the same router. You may be running something else. And I know I'm repeating myself, but I'm trying to get through to you. Okay? Then when you get out there, you may run into a router that you've never seen before in your life. So, they say curiosity kills a cat? Well, not in this case. Here, you better be curious. And you better figure it out. Because that's what employers want. They want people who are curious, who are ambitious, who are able to solve the problem. And the way you solve the problem is either you know it or you know where to get it. But anyway, I'm going on a tangent. There's what IPSLA is. I'll see you guys outside the lab. Slightly different, huh? We had to put in monitor. Monitor what? Well, we can monitor many things. You saw that. Well, we say, okay, we're going to give it a number one. And then, well, what are you monitoring? Well, I'm monitoring weird looking IP, ICMP echo that we have to put in there. And you had to put in the destination address and you had to put in the source address. And then when you do the schedule, again, you got to put in monitor, schedule, and then the number. And then you go and say live forever, start time now. This is a different iOS. So you do it differently. I said it. Not all routers are equal because not all routers will have the same iOS on them. So if you go from simulator to simulator or if you go from router to router, they may be different. All right. But again, the books that you're studying, stick to what they tell you. Stick to what they tell you in the books because that's what's going to be on the test. Okay. Now, but again, you're not, I'm telling you, it'll be a surprise to me. And if you do have to configure in your test, and you gotta show me, well, you can't show me proof, but if you have to configure an IPSLA in your exam, I want you to tell me. And then I will retract my words. That's how sure I am of that. Okay? You'll be asked questions. I'm not saying you won't, but of the concept that we talked about. All right? So, again, every simulator, every router is not equal. You may have to do it differently. What you need is curiosity. Wait a minute. It didn't work this way. How can I? Know it or know where to get it. I already said it. Know it or know where to get it. And just be curious enough to figure it out. All right? That's real world right there. But not everybody knows everything. You got to figure it out. See you in the next one.